You might know Bosch from consumer goods, industrial technologies, and that's one of the world's largest automotive suppliers. Today, I won't be talking about microwaves, oven, or stuff like that. We keep in the automotive area. That's where I'm from. Yeah, I have more luck than the colleagues from yesterday with the remote. So what am I going to talk about? Test automation. We keep the topic, but from a different scope, from the automotive scope. And I don't know if any one of you participated yesterday on Petra's presentation. Well, yeah, I can see the hands. Good. So it was a very interesting topic. It will be similar, but the key message and the scope will be different. So what am I going to talk about? First, I introduce transmission systems, that is my field, and show the test automation through this topic, and introduce safety-critical software and these topics. So we are dealing with cars. Everyone loves cars. So what do we see in the picture? Powertrain. So what is the powertrain on the picture? Basically, it's the engine, clutch, the gearbox, and of course, shafts. So what is the main purpose of this? To transmit mechanical power to the wheels so we can drive. Okay, and as I'm from transmission control, together, the clutch and the gearbox is the transmission system. And what does the gearbox do? It modifies the shaft torque and shaft speed. So the proper speed will be present on the wheels. And yes, this is a transmission unit. What can we observe on the picture? So, of course, we can see the control unit, transmission control unit, provided by Bosch. What else? Well, shiny metals, that's the housing, and the other parts we cannot see. So these would be the gears, the shafts, the electric motors, and sensors, of course. On this picture, this is a dual clutch automatic transmission. The difference between automatic transmission systems and manual is that when we drive the car and want to shift, the manual way we do the shifting, and in automated solutions, the automatic transmission system does this. Okay, after the outside, yeah, it worked for the first time. After the outside, let's take a look to the inside. Okay, here, as I mentioned, you can see the shafts and a lot of gears. So how does it work in the automatic solutions? So if we put the proper gears to position, then we can select the proper speed and the proper torque and speed ratio to the output. And in this particular solution, we have two actuation system, one for the clutch, we have to control that, and of course, to move the gears into position. That would be an electromagnetic solution in this gearbox. Okay, but what does Robert Bosch and the Bosch software has to do with all this stuff? For automatic transmission system, Bosch provides the transmission control unit, so it would be the hardware. Then there are some drivers to be able to work with the software, so there we have the I/O drivers, and then we have a middleware software. Normally, our customers like to keep the application development to themselves. What does it mean? It means that they want to implement themselves how to shift, when to shift, and the strategy itself. That would be the customer application on top. So, but then what does the Bosch software main functionalities are? Well, as I thought, this would be to make this happen, to realize this strategy. So to control the actuators, these would be electric motors. And of course, to process a lot of sensor information. So how could a customer application know when to shift, how to shift? Through a lot of data, which we gain from sensors. And then one of the most important part is error monitoring. Okay, so these are the main functionalities of the software. Besides that, there are plenty of fields, but this is the core. Okay, now we know how the transmission controller works and what are the main functionalities. But before we move on to testing, there is safety critical systems which we want to talk about. So the ones who participated on the presentation from Petra yesterday heard this stuff or similar, but instead of showing examples, I have a different approach. So what we call safety critical systems. These are the systems where a malfunction can cause a lot of damage, loss of life or serious health damage, or property damage, or even damage to the environment. These are safety critical systems. Obviously, a car is a system like this, so there are some special standards and rules which apply. So you don't have to have a university degree to figure that all out by yourself. That you need a different testing approach for software which you take from off-shelf or a game, or if you have malfunction in a car. So in the worst case, people can die. Of course, we want to avoid that. So therefore, there are a lot of standards which specify a lot of things: how to develop, how to test. What does that mean? It means that these standards specify a lot of things, test design techniques at each test level for the development cycle. Okay, but what does it mean in testing? So this is not the U model, this is the V model, just to be sure. So I want to focus on the differences, with what you can see on this slide. So nothing new, V model, as I mentioned, but on each test level, there are specified test design techniques which you can choose from. Of course, it doesn't mean that you only have to do and implement those test cases which are required and defined for that specific test level. You can do a lot of things, but if you have an audit or if you have a legal case, nobody's interested in the other test design techniques, but everyone will check that on that particular test level, the ones which were specified by the standard was used. What does that mean? It means that you have a reduced test scope, and of course something more which is functional safety dependent. What we do at Bosch, it's not a must. Yesterday, some of you saw a solution where unit tests were implemented in model in the loop or with a model simulation. We use hardware in the loop for each test level. And of course, most of the test cases focus on malfunction. Okay, so perhaps it would be easier to take an example. So what could be these requirements which we have? Like to set the speed of one electric motor. As you remember, these were the actuators for shifting gears. So if you want to, if we have a requirement to set a specific speed in the range, then the test design techniques which we have to use is reduced. For example, in this case, we had to use boundary values with mixing with equivalence classes and fault injection. It's not a big deal to implement this. What is the hard stuff? That there are not only two requirements in such systems, there are a huge amount of requirements, and the customer demands 100% test coverage for that. So in this case, we can have a mock customer application. for the interface, and that we have to test through all the test levels. If this requirement is functional safety has functional safety relevance. Okay, then there are a lot of requirements. The test design is almost obvious. Then what can be done? What could be a good solution to make this activity and make this testing interesting? We thought that these two would mean that we have to do a lot of test automation development. Okay, and how do we do that? We have the TCU, of course, lab car, off-the-shelf software, and our own test automation executable. Okay, on the TCU, the transmission control unit, we have the software running, and then what is the part of the lab car? Lab car is hardware loop, so that the TCU can think that it's inside a real car. So it stimulates the input and output signals of a real car. And then, as there are standard communication channels within the automotive industry, there are a lot of off-shelf solutions which we can use. And to add own implementation and automation to these softwares. Okay. So far, this was not different than you would test a normal system, except for the functional safety test. What would be the difference in test automation development? So first, how to start is to check return on investment. You would do that normally for all testing and all automation. And then, in our example, we had to check whether the test specification was right for the automation as well. So it's not that obvious. So a tester could understand, for example, that the value is asymptotically syncing to 0. How would you implement that in test automation? You have to double check this stuff. It was a hard lesson learned for us. Then here comes the difference. No, too soon. It was another specific criteria which we added to have a design which focuses on object orientation and those guidelines. And then the difference would be the validation. So this standard has a very large topic. That all these tools we use for testing should be classified, qualified. So basically to test the tester tool and to assure that it does the right thing. And then if we want to start over, then we have to repeat all these steps. So basically the difference was only the validation in this case. Okay, how to proceed? What will the future bring? So whether it will be just optimization. Currently, the speed of shifting normally is around 100 milliseconds. The fastest solution is around 8 milliseconds. Who would optimize that? But there could be new solutions. Currently, there are 6 to 10 speed solutions on the market available. Perhaps it's not the best number of gears, or there will be new solutions for that. Or I don't know if you read the news or heard that the automotive industry tends to complete electrification with autonomous driving and stuff like that. Or perhaps brand new technologies arise. Can happen. What I know for sure, that all these systems will be safety critical systems, and if you want to test and do automation at this, then you have to consider these standards, and you have to consider validation and the standards in this. Okay. Thank you very much for your attention. Any questions?
Can you give us an example test design technique in functional safety?
Yeah, so as I mentioned, I think I already did that with the fault injection test case. What does it mean? And unit test levels, I thought that we do all tests in a hardware in the loop. It means that we have to corrupt the register values at controller level. That would be a technique which is specific for function safety.